Dear viewers, Assalamu alaikum. In our previous video, we discussed that how we can locate the adsorption of our compounds on the surfaces of the metals and metal oxides. We also discussed in second tutorial that how we can make different surfaces and structures of materials like silver oxide, copper oxide, iron oxide, etc. So today we will discuss that how we will make carbon nanotubes, the structure of carbon nanotubes. We discuss that how many types of tubes can be drawn, and then we will discuss that how we can locate the adsorption of certain compounds on the surfaces of carbon nanotubes. So we will take an example. So okay, we are going to start from Material Studio. So we will create a new project. We have already some existing, but I am going to make a new one. So here I am going to write the name of our project, and it is carbon nanotubes adsorption. Let's pause. So I have made this carbon nanotubes adsorption. Okay. So for this one, first we need to draw our compound that we want to adsorb on the surface of carbon nanotubes. So here I am going to show you. We will open our new document, that is 3D atomistic, and we have already shown all these uh, features in our previous videos. So first I would like to show you some carbon nanotubes, then we will discuss the adsorption. So if we look at here, we have templates of carbon nanotubes we can import. So go to file, import, and then go to structures, and here we have an option and folder of carbon nanotubes where templates of carbon nanotubes are present. So all these are different carbon nanotubes of different carbon atoms. So here we have five carbon atoms, then 6, 7, 0, 6, 6 means the 6 carbon, 6, 6 double carbon. I will show you. And then 7, 0, 6, 6 capped, or 5, 5 capped mean the one side is capped and the other side is hollow in the tube. So here it is a 6, 6 capped, but it is long tube. I am going to show you that what is long and short tubes. So short tubes, usually if we look at here, we are going to take carbon 6, 6, and I am going to rotate it. So we will observe that it is only this short tube and it is carbon 6, 6. So how it look like if we I want to show you carbon's difference between carbon 6, 6 and carbon 6, 0. So it is carbon 6, 6. I am going to make it display style CPK. Now it will be clear. So if you look at here, carbon 6, 6, this is carbon and this is carbon. So it is carbon 1, 1, carbon 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So it is carbon 6, 6 carbon nanotube. It is a short tube. And now if we look at another, so we will go to file, import, and here we have carbon 6, 6 capped. So it is a long carbon tube, carbon 6, 6, and it is capped. I'm going to rotate it, and so it shows. So here it is capped from this end, and the other end, this end is hollow, and it is a long tube. So it contains a lot of atoms in this tube, but it is again it is carbon 6, 6. If we look at here, the okay, and display style CPK. Okay, so if you look at here, it is also carbon 66 long tube. And now what is carbon 60 or 70? So we have template of 7 to onward with 7. Like here we have 7080. So if we are going to import 70, so it is a short tube, short, and it is like display style CPK. Okay. Okay, now if you look at here, this is carbon 1, 2, 3, 4, 5, 6, and 7. So these are the 7 carbon tube, and it makes this like structure hexagonal. Okay, so these are the different types of carbon nanotube templates available in Material Studio. Okay, now we are going to discuss that how we will locate the adsorption on the surface of carbon nanotube. So we will go to new 3D atomistic. So here we can draw our structure from this drawing tool, or we can draw structure in CamDraw or Discovery Studio. In our previous video we discussed that we can draw in Discovery Studio, or we can file new molecular window, but here we can draw our structure. But today I'm going to show you that we can bring compounds from CamDraw also. So today I'm going to make a CamDraw structure and then we will import. So here, like here we have a benzene structure, and I'm going to make it like colorful compound it should be. So this type of structure. So I'm going to take this structure, so copy this from this CamDraw. It is more easy, so I prefer CamDraw or Discovery Studio for designing small molecules, because in Material Studio it is somewhat difficult. It's not an easy. So here directly we will right click and then paste. So this is our structure, and so this is our structure in 3D atomistic here in this file. And now I am going to geometry optimize this structure, and we will go to this tutorial calculation. So it is forcite calculation. So in forcite we have an option of energy optimize geometry optimization, and we will select fine, or we can also select ultra fine geometry optimization. For energy, force field, compass, force field charges, force field assign, quality is fine. Electrostatic is atom based, van der Waals is atom based. Here we have different options, group based, or so we will select here atom based. So this is our geometry optimization setup for foresight calculation. Now it will calculate when we run it. Now this dialog box shows that it is running, and it is now successful. Job is completed. Can close this. So this is our status of our structure. So it gives all the different options present in this molecule. So geometry So it gives convergence tolerance, energies in kilocalories per mole, force, displacement, and some other properties are also shown here. But we have this. This is 3D atomistic convergence. This is atomistic energies, and this is our molecule after geometry optimization. So it is present here in 3D atomistic folder. Now the geometry is optimized. So if you look at here, it is like this. I'm going to change its display style, then it will be more clear, like ball and stick model. So it is like this. Okay, now it is geometry optimized, this structure, and we can rename this folder also and save. So we can rename it as it is our compound. So I am writing. Okay. So we are going to close this folder, and now we will go to again this carbon nanotubes, and then we will go to import. We have selected for adsorption location of that compound on the surface. Okay, now I am going to change the display style so that it looks more easier to me. Okay, and now we build this structure, and we will go to build surface, cleave surface, and here I am going to write here 1 1 and 1. Because if it is more thick, it will create more atoms and it will be difficult to run our annealing. Leave rule is default, and face width, we can select that face with the carbon, or if here we don't have hydrogen or other atoms, like this. We can recleave this structure. We can recleave this surface, and we will go to again build surfaces, recleave surface, and then I am going to make it some longer, like here recleave surface thickness is 3, and recleave. So if you look at here, it is now somewhat longer. Okay, now we are going to build symmetry and making a supercell with the value of 3 and volume, and to create supercell we can make it 4 or 5, but here we look at here is enough for us for adsorption location. So we have 3 supercell. So if our adsorption location can be in between these surfaces or on the surface, outside the surface, so other structures will be remain same. So we can make it 4. So build symmetry supercell. If we look create supercell from 4 here, so it will be more. So I am going to undo this first. Undo. So I am going to make it build symmetry. So it's okay. We have built it 4 surfaces of the carbon nanotubes which are in row, and now we will go to build, and then we will go to crystal tab. We can choose the direction in which direction we can. Okay, so here we build this vacuum slab. If we look at here, it is the vacuum slab. It is in the direction of C, but we don't need in this direction. We need the surfaces. So it is the hollow side which is on the vacuum slab. So our compound will target from this side. So we can also select this type of surface, but here we don't need this. And if we want to delete our folder, let's suppose we are going to delete this one. I'm going to delete this. Okay. And I am going to make this for another direction. So I am going to make it in the direction in which the surfaces are exposed. So I will make it again. So build surfaces, cleave surface, and in this time I am going to make it as -1 0 0 0. Thickness is 3. Again, we can also check the surfaces orientation of our this V and U. So here V is along y-axis and U is along xy plane. Okay, now we are going to cleave this. Okay, now if we look at our structure in -1 0 0, it will be like this. Okay, and if we look at here in 1 1 1, it was like when we cleaved, it is like in the same direction. So now this we will build symmetry supercell, and we are going to make it 4 and 4. Okay, now it is build crystal and then build vacuum slab in the direction of C or A. Vacuum thickness is 12. and crystal thickness is 36. Okay, build. Okay, now if we look at our vacuum slab, it's like this. Now this these surfaces are for the adsorption of the molecule. Now these are the surfaces, and in this 5111, if we look at this and we want to, here we have, if we want to build it, then it will produce uh, crystal. If we make a vacuum in the direction of C, it will be like this, and the hollow are on the surface. So we can make adsorption locate either in this type or in this type. Okay, so I am going to show you in this type. Now we will go to adsorption locator, calculation. For this we will select our compounds or the surfaces which we want to locate for adsorption. So for this I am going to zoom it, and I need only these surfaces, so I am going to select this. So I will select these surfaces. Okay, so after selection we will go to location in adsorption locator, and here we will select the option surface region defined by atom set, and here set maximum adsorption distance to 5 angstrom, and add the selected atoms, and then we will select these atoms. Now we will go to setup, adsorption locator calculation setup, simulated annealing. The quality is fine, we can fine or ultra fine. Going to select adsorbate, so adsorbate is in present in this folder which is compound. So now we have selected our adsorbate. For energy we are going to select compass, charges, force field sign, quality is fine, and here electrostatic we will go to atom based. Van der Waals also atom based. We can also select all these properties. Here we will fix energy window. So energy window, wait it for some time, will take some time. If we look at here, it is average total energy minus 4.847, total energy is showing minus 7.498, interaction energy minus 18.451. So it is running in different cycles. Van der Waals energy minus 18.41, intramolecular is 10.95 kilocalories per mole. So it is still running, adsorption is still running, and if we look at the status, it is showing that it is running. After it finishes the job, a dialog box will show that the job is finished, and it will show us the energy values, a table in which adsorption energy values and the poses we can select from that table. So I'm going to show you Here is the energy distribution graph, and here we have total energy, average total energy, van der Waals, and electrostatic and intramolecular. So all these are the energy value graph. So it is still running. It is cycle 1 of 5. So we have to wait for up to 5 cycles. So it is 1 of 5. So we are going to wait for 5 cycles. Okay, our job has been completed, and as we selected the fine option, so it took a lot of time, almost an hour. If we take an option of medium or curse, it will take less time. So now this is our results. This table represents the energy values. I'm going to make it, and okay, now this gives us different energy values. So here is the total energy. Adsorption energy is minus 19.12, rigid adsorption, and these are the values. So now we can, if we look at the different poses, so here are all these different energy values. The most negative is the first one, which is minus 19.129 adsorption energy in kilocalories per mole. So it is from this table. So I am going to select this pose so I can open this pose. So here, if we look at our adsorption of our compound, so we can check that what will be the position. So it looks that this compound is more hydrophobic in nature, and so it is not going to adsorb on the inside the pockets. So it looks that the position of adsorption is here for this compound, and so this is the compound which gives that much energy. So we can also look at some other examples, like here if we want to check this pose. So it shows that the adsorption at this position, which is also on the surface or in between these tubes. So at this position, like this, and we can also check some other results, like here. Okay, so in this way we can obtain our results that at what position it is going to attach, but most of the time it looks like that it binds inside the curves of these nanotubes and not on the this concave side of the tubes. So after that we can make our results, like if we want to make poses, like here if I am going to make final pose of this structure. So I will select the lower positions and I am going to remove these atoms which are not needed. So we can go to display style and none, close. Okay, so we are also going to remove these atoms, so I am going to only select single tubes. So we can either we can delete these atoms or we can remove by none. By control option we can select all these, and I am going to we can remove or delete these atoms layer, and I'm going to display. Now I'm going to display style and make it CPK. Okay, and for this one, for this compound, double click on this compound, sorry, double click on this compound, and we can go to display style and ball and stick. We can increase the thickness of our ball up to 6. We can color by custom color. These are also carbon. I am going to make these as cyan color. Okay, now if we look at, can make different poses. Now if we look at the force field, we can go to option. Here we have this option of field for this. So here we have force field. Now these are the force fields, and we can also make changes in the display style of force field, and we can select here field, then volume. We can change the color of force from here, color by field values, show box or not, and the volume, transparency. Okay, now it represents the volume. These are the force field volume where our compound can be bound. And go to display style, and we can also remove this force field, lattice, none. Okay, and the background can be dark from here, because in force field it's better to make it dark. So this way we get our force fields for our compound. So here are the different force field values where our compounds can be bound. Okay, so today we discussed that how we can make nanotubes, what are the different type of nanotubes, and then how we can check the adsorption of our compounds on the surfaces of carbon nanotubes, either from hollow side or on the surface sides. So if you like my video, please subscribe my channel and share my videos. Thanks for watching.